All right. Welcome to section 5.4 complex fractions. I love this section. I think it's a fun section to work with. Now, I wrote some stuff to save time. The key here that I'm going to talk about, if they give you 3 or more fractions, like example 2 gives us 4. 1, 2, 3, 4. 4 different fractions in one expression, basically. If they give you 3 or more, the easiest thing to do is multiply every single one by the least common denominator, and it will go away. Now, what I mean here, and then I'm going to show the y down here. What I mean is multiply them all by the LCD. And those of you that like cross-canceling, this will make complete sense and you'll love it. You'll probably run with it right away. If you don't like cross-canceling, you might have to do the long version a few times to get used to it. So my least common denominator, I have an x, a y, an x, a y, so it's xy. If I multiply every one of these by my LCD, I'm multiplying this by my xy, so my x's cancel out, and I'm left with y. Here, my y's cancel out, I'm left with x. Then on the bottom, my x's cancel out again, I'm left with y. My y's cancel out here, I'm left with x. I can't do anything with this. These are opposite, but these are the same. So if I try to negate one, then one will always be different. So there's my answer. Done. Easy. Example 2, that's a complex fraction. That's all it is. Why is the big question I get with students that say, why did the LCD go away? Why don't I have a fraction over a fraction? And I'll show you why. If you change these to make them equivalent, I would need to multiply my first one over x. I would multiply each one by y to get a y over xy. Then this one, to make an xy for a denominator, I need to multiply by x. So I'm adding x over xy. Down here, I multiply both by y to get my y over xy. And here, I'm missing an x. I multiply each one by x to get an x. Then what happens with that is I would have y plus x over xy over y minus x over xy. This is division. When we're dealing with fractions, we're talking division. So you know that to solve a division problem with fractions, you take the reciprocal and multiply of the second one. So my reciprocal is xy over y minus x. This is the long way. If I changed every one of them to make them equivalent fractions with denominator xy, I would have this whole piece and combine it together and think of it as this one divided by this one, this piece divided by this piece. So I would flip and multiply. When I do so, the LCD goes away because I made it the same. So I'm left with x plus y over x minus y. That is the y we can skip. Now this is only the quickest route if you have 3 or more fractions. And go ahead and shoot me your questions. You can leave them in the discussion forum if you want to. I've already had a few. I'm going to try to shoot videos of those later. Some of the questions I've gotten. Section 5.1, number 51 and 53 were the most common. So I'll try to work those out. Now, example 3 gives us our alternate, where they only have 2 fractions total. They give us an x minus 2 over x squared minus 9. That's one fraction, all over x squared minus 4 over x plus 3. When they give you less than 3 fractions, I only have 2 fractions total. Well, now it's easier to think of this as a division problem. It's quicker than trying to multiply by the LCD. I think it's just an easier way to think. So if I take my x minus 2, now I'm going to include the factoring right now, just to save room, because I don't have that much room. I'm sorry about the whiteboard I have. But I'm going to factor this out. So I have my x minus 2, perfect square minus perfect square, x plus 3x minus 3. Now I'm going to flip and multiply. So I'm going to take my denominator, make it my numerator. I'm flipping multiply, I'm taking the reciprocal. And I have an x squared minus 4. That's a perfect square minus a perfect square. So I have that. Now again, you can extend your fraction bar and think of this numerator as this times this, or you can keep them separate and know that anything in the numerator on either one of them is fair game with anything in a denominator because it's all multiplied together. So I like starting and working left to right. X minus 2, do I have it anywhere? I sure do, right there. X plus 3, is that anywhere? It's right there. So that goes away. I'm left with 1 on top, don't leave that 1 out, times x minus 3 times x plus 2. That's example 3. So again, the biggest key with these is factoring. That's it. The biggest issue, you got to factor first. Once you've factored, then it's a matter of just whittling things away. Once you factor out, because you need that LCD. Sometimes they give it to you, sometimes you have to factor to find it. So let's go to example 4. I only have 2 more examples in this section to talk about. A 1 minus 4 over x squared. And then here they try to throw us off by giving us 3 fractions. I don't care how many they give us. I know that if there are 3 or more, then I need the LCD. In this case, I have a 1, because it's 1 over 1, 1 over 1. I have a 1, I have an x squared, an x squared. So x squared is my least common denominator. It's the smallest value that all of them divide into. So what I'm going to do is I'm going to multiply everything by x squared. All of these, these 2, these 3. So what I end up with is an x squared, 1 times x squared. X squared divides into x squared once, so I have minus 4. That's my numerator. Remember, my denominator falls out because I would flip and multiply anyway. It's going to go away. Here, they just give me 3 of them. So I have x squared times 1. X goes into x squared x times. So I'm left with just a 1x. X squared divided by x leaves me with 1x. Because x times 1, 1x. X squared cancels out, leaves me with a negative 6. Now, again, I have to factor. I have a perfect square plus or minus a perfect square. Gives me, I don't know why I wrote 3, gives me the plus or minus. And then down here, whoops, I really like 3 right now. Okay, so I have x plus 2x minus 2. Here, x squared minus x minus 6. I have my x minus 3 plus 2. That gives me a negative 6 and a negative 1 in between. Now I look for sames. X plus 2 goes away. I'm left with x minus 2 over x minus 3. They gave me 5 fractions. Well, these aren't fractions. They gave me 5 different pieces in this one. I multiplied every one of them by the LCD. That made it go away. I'm left with a numerator and a denominator to work with. So, not really bad. Pretty simple, I think, once you get the hang of it. If you get the hang of this trick, then it makes these pretty quick to do. If you don't like that trick, if you really don't like cross-canceling and thinking that way, you can change every single term to a fraction with the same denominator. Make them equivalent fractions and add everything together. You just got a couple extra steps involved. Now example 5. I'm doing this one because it's just a little bit different way to look at complex fractions. So in this case, the way I'm going to tackle this one is, because you never know what's going to happen, my 2 is just there. It's a 2. I'm going to leave it. I'm going to worry about this piece here. And what I do with this piece is I'm going to multiply by the LCD. You don't really, there's different ways to do it. I'm just going to multiply everything through by 3 to see what happens. When I do, I have a 9 on top, and then I have a 3x, and plus 1. 3x plus 1. Now I see something a little easier to work with because I simply have an LCD of 2x plus 1. Now I'm back to two expressions and I need the LCD. What's missing? I can write this as 2 over 1. That means I'm missing 3x plus 1. When I do that here, I'm able to just combine my numerators because I know I have just made an LCD of 3x plus 1. So when I carry through the work and I distribute the 2, I get 6x plus 2 minus 9, which oddly enough is the same exact thing we did on another one, I believe. The book does that every now and then. So I end up with 6x minus 7 over 3x plus 1. And I think that's all I wanted to do for section 5.4. That's it, because that's the basic, that's the thought process I want you to use for section 5.4. When they give you complex fractions, don't let terminology throw you off. Just know that means there's several fractions involved, even though there's one big fraction. You have several involved. If you have 3 or more, here's basically 3 terms. You can do your LCD, multiply all the way through by your LCD, and it goes away. If they give you a rando over here, just a number, I'd hold on to it, because you never know when something over here is going to work out and the x's go away and you can just combine a 2. Makes it quick and easy. It didn't in this case. We had to combine it by multiplying by the LCD once we got to this step. Okay, complex fractions, I think you're going to love them.